Okay, all right. So let's start with a bit of a 16C revision. I mean, it's been like 2 weeks since we last did this one, so I don't know how much you guys remember. Now, there were two main concepts in 16C. Do you remember what those two were? Sahab?
It was...
Okay, hint for you. 16. Okay, I'll give the hint. So 16C was about variance. So that's one concept, and the other one is interquartile range.
Yeah.
Right? How do we calculate the variance again?
It was EX.
Var x would be, yeah, what's the formula?
It was EX.
E of, not just x, E of something a little bit different.
X squared.
Yes, E of x squared. Good, and then?
Is it minus?
Minus, yes, minus something.
Mean squared.
Minus mean squared. Perfect. Good. See, it's still there somewhere, right? Now, how about the interquartile range? How do we find the what's the interquartile range?
It was the value.
Yeah. Is the value good? Yes.
In between, like, is in quarters or?
Yes, in quarters. Yes. So interquartile range is essentially equals to the upper quartile minus the lower quartile, right? So let's say the upper quartile is B and lower quartile is A, right? So B and A. How do we calculate B and A again?
A was was it 1 minus that as A? No.
Not quite.
Because I remember it had something to do like quarter. It was like it has to equal 0.25.
Yes. So to find A, let's say to find A, right? You do have something equals to 0.25. That's right. But what's
the area?
Yeah. The area. Okay. And how do you calculate the area in in calculus? How do you calculate area?
Is it antiderivative?
Antiderive. Yes, correct. You antiderive from what value to what value?
From was it 0 to A?
From negative infinity, technically, right? To A, right? And then of the function fx. Yeah. Then the answer is 0.25. Okay, then how do we find B then?
B was, it's equal to 0.75.
Yes, antiderive from the left to B of fx would be equals to 0.75. Okay, good. Did you remember this one? Yeah, okay. Let's just try a question. I'll just put up a question. Let's try it and see if you can do it by yourself. So I'll give you guys a head start. So Emily, if you're listening to the recording right now, you should also pause at this point and then attempt the question yourself, and only continue once you have done the question. I don't just look at my answer first, ideally. Okay, so the question was okay, let's test a standard deviation one and a interquartile range one. Okay, so first let's calculate the standard deviation. What's the standard deviation again?
Variance in the function of data given.
Yeah. How's it related to variance? Right, so standard deviation, or SD of x, and another symbol for that is sigma equals to standard deviation. How do we calculate standard deviation?
Oh, isn't it
It's related to variance.
Isn't it E? No, it's...
No, it has something to do directly with variance. You have to calculate variance first, and then you do something to it to find the standard deviation. What do we do with it? It does something. You have to do something to variance, right? But what do you do with it? You square root variance. Okay, so variance is just the square of standard deviation. All right, so that's the definition of variance. So yeah, standard deviation, you just need to square root variance. That's it. Okay, all right. So yeah, so how get some paper out? Here, you can grab these sheets if you want, and just try out this question. Calculate the standard deviation of x. And this question will be non-calculator. Okay, all right. Another quick recap. How do we calculate mean, which is expected value of x, right? And to calculate this, you enter the right from left to right of x times into the function fx.
Oh, so there's another x. Oh,
Yeah.
2x squared.
And then e of x squared would be the same thing. So would enter the right from the left to right, but then instead of timesing x, you're timesing x squared. So remember, whatever this is, it matches up with the big X in the e of something function. Okay, I'll start working through this question as well. Okay, the answer is up. When you're done somehow, make sure you check your answer and see if you got the right one. Alright, so that was the standard variance, standard deviation or the variance question. The next one would be an interquartile range, but this one is the broken down question. Then after this, we'll try one that's like a combination of the two. Okay, next question will be question 3. Let's try this one out. Okay, I'll start working out the question as well. Okay, question 3 will be a calculator one because you need to calculate cube root of something. Do you have a calculator?
I think so.
Yeah, take it out. You need to use the calculator for this one. The answer will be a decimal. Note that when you're doing intermediate answer, you have to use more decimal places.
Oh, this is a thing question.
Yeah, this is the
variance.
Yeah, not variance. Yeah, it's one where n to the right from the left to the a value equals to the area, which is 0.25. That's for the lower quartile. Okay, so the answer is up. Just know that when you calculate the interquartile range, use the one with more decimal places. Yeah. So you have to write both versions, the one with more decimal place and then the rounded version. So the answer for the first two parts will be a rounded one, but to calculate the last part, you need to use more decimal place. Otherwise, there could be rounding error. Now, so those were two questions that were separate, right? The first one was variance, and the second one was interquartile range. Now we'll try one question that combines both of them. More likely to be in your exam. It's something that combines both of these concepts. Hi, and that's question 8. Let's try this one out. Okay, I'll start working through the question as well. Okay, so how are you done with question A? Yeah? What did you get?
0.7321.
Yep, correct. That's good. What did you get for the mean?
806.
Yep, which is 4 over 3. I should simplify that first. So that second part is actually doable without a calculator. Yeah, 2 over 9? Okay, good. All right, now, so that was like a basic question, right? Now I'll go through 2 more questions on this chapter that is a little bit different. Okay, the first one is question 7. Now, this one is actually, it has a concept from unit 3. It has a very important concept from unit 3. See if you can recognize what that concept is. So, how do we find interquartile range? It's lower quartile, upper quartile minus them. Easy, right? Let's see. So, lower quartile. So, first we'll find the lower quartile, right? Which is A. So, when you interderive from 0, because the function is defined only for x is more than 0, from 0 to A of 2x e to the power minus x squared dx, this would be 0.25, right? How do we do this? How do we antiderive this thing, this weird thing here?
Could you separate them?
No, you can't. So this is a function times another function, right? But there's no product rule in antiderivative. How do you do this one? Remember this? Consider. See how this is e to the power something? And that something looks similar to the derivative of, like when you derive it, you get sort of like 2x, right? So remember the idea of when you consider deriving this term, right? Just deriving that part. So this would be equals to minus 2x e to the power negative x squared. Does that make sense? Yeah? Therefore, when you antiderive negative 2x e to the power minus x squared dx, this would give you back e to the power minus x squared, right? Yeah? But here, it's antiderived just 2x. So just this bit here without the negative. What do we do? Right? Because we know when you antiderive this exact thing, you would get e to the power negative x squared. And technically plus c.
Multiplied by negative 1.
Yes, that's right. So this is the idea that we have to multiply negative 1 to the front, and then what's inside here will turn into negative 2x. Negative, right? You have to multiply negative 1 twice. So the idea is that, so this is the same as times negative 1 twice, right? Because when you multiply it twice, it cancels each other out, right? So when you multiply negative 1 twice into this expression, the answer is still the same, right? The answer is still the same, but then when you take one of the negative 1 and multiply that in here, you would get negative of 0 to a of negative 2x e to the power negative x squared dx. You times it twice because you can't change it. Right? From here to here, you cannot change it. It must be the same. Right? But you want the negative in here. So remember, previously we had something like antiderive of, let's just say, we need to times 2 times 1 over 2. Remember this one? Yeah? So you times it by 2 numbers. But when the 2 numbers, when you multiply together, it cancels each other out. Right? And then you want the 2, to multiply into it. So it will be like 2 something over something. Right? You want the 2 in here, but that's why you have to multiply 1 over 2 to cancel that out. So in this case, you are multiplying negative 1. So to cancel out the negative 1, just multiply by another negative 1. Does it make sense? Yeah? So this is the derived by recognition, the concept from unit 3. Alright? So yeah, so once you've got up to this point, so here, when you antiderive this, you get that, which means at this point, we can just write that is equals to negative of e to the power negative x squared from 0 to a equals 0.25. Make sense? Yeah? And then you would just substitute the values in. So e to the power negative a squared minus e to the power 0 equals to 0.25. And you can work it out manually or you can end solve it. Let me double check if this question is, yeah, it's a calculator one. So technically you can end solve this one, but if you want to work it out manually, you can too. So expand that would be, this one is just equals to 1, right? So expand that would be minus e to the power negative a squared plus 1 equals 0.25. And then bring the 1 over there. So I've got negative e to the power negative a squared equals to negative 0.75. Multiply both sides by negative 1. E to the power negative a squared equals to 0.75. And so negative a squared would be ln of 0.75. Okay, so then a squared would be negative ln 0.75. And so a would be square root of negative ln 0.75. All right, punch that into the calculator and you should get the answer, which is negative ln of 0.75, which is 0.53636. Okay, make sense? Yeah, so that's the a value, and we need to find the interquartile range. So we need to find the b value. Okay, I'll leave this one here. So how? Well, you should try working out the upper quartile. Alright, so don't need to redo the lower quartile, just work out the upper quartile. So based on that concept there. Is it not?
No.
Did you get negative ln of 0.25?
Yeah.
Yeah, let's see. You might need to put a square root of negative because ln of 0.25 is a negative number. So the negative goes in front of the ln first and then you square root that answer. Remember, ln of a number that's between 0 and 1 will give you a negative number, yeah? Alright, I think I will probably save the other concepts, the other questions for later. Everyone is here. You guys will need to redo this one later. Alright, moving on. So next is the, okay, we're going on to the chapter. Okay, 16e, cumulative distribution function. Okay, alright, 16e. Or also called CDF. Remember how you guys learned the PDF? Probability density function? Remember that? Now it's the cumulative distribution function. Right? It's a little bit different. So remember how we were doing that chapter there where there's like binomial CDF and binomial PDF? And when would we use binomial CDF?
When it was like 0 less than or equal to x less than or equal to another number.
Yes, so when the value is between the range, right? That's when you use the CDF. And then in this chapter, you understand how to actually calculate the whole CDF thing. Okay. Actually, we'll take a short break, an earlier break today, and then we'll start on the content in the second half because you need to break your fast soon, right?
Yeah.
In like 3 minutes, right?
Yeah.
Okay. Yeah. I'll pause. I'll stop the recording for the first half here.